The aim of this experiment is to determine the equivalent resistance of two resistors when they are connected in parallel. The material required is two different resistors R1 and R2, an ammeter, a voltmeter, a one-way plug key, rheostat, connecting wires, battery or battery eliminator. So set up the circuit as shown in this diagram. Make sure that the resistors that you are using have been connected in parallel, and further the voltmeter is also connected in parallel with the combination of resistors. Then the ammeter, the source of current, which might be a battery or a battery eliminator, a one-way plug key and a rheostat are all connected in series. Be very careful about the positive and the negative terminals, so you have to connect them the way they are shown here in the diagram. So you can refer to this diagram for connecting your apparatus. Let us now perform the experiment. So as you can see, the rheostat, the ammeter, the battery eliminator, these all have been connected through main wires in series, and then we have two resistors of 10 ohms each, which we have connected in parallel, and along with them we have a voltmeter which is also in parallel with respect to the resistors. So using the rheostat we will adjust the readings. So now since the current is already on, you can see that the reading in the ammeter is at the middle of like 0 and 0.2, that corresponds to 0.1 ampere or 0.10 ampere, and at the same time the reading in the voltmeter is 1 volt. Now if I change the readings, we can have a second set of readings. So if it corresponds to 1.14 ampere, you can see that the reading in the voltmeter has also increased to 1.2 volt. Similarly, you can take multiple readings which will help you to prove that when the resistors are connected in parallel, then the resultant resistance is equal to the sum of the reciprocals of the individual resistors. Let us now check with the observations. The least count of our ammeter is 0.02 ampere, and there is no zero error in the ammeter. The least count of our voltmeter is 0.1 volt, and there is no zero error in our voltmeter. So there is no need of any zero correction here. For the observations, when the reading in a voltmeter was 1 volt, the ammeter reading showed 0.2 ampere. When we changed the reading of the voltmeter to 2 volts, the reading in the ammeter got converted to 0.4 ampere. And when the reading in the voltmeter was 3 volt, the reading in the ammeter got converted to 0.6 ampere. So when we take the V by I ratio to calculate the resistance, we are getting a value of 5 here. And since we used two resistors of 10 ohms each, if we want to verify it experimentally, let us calculate the theoretical value. So 1 upon resistance in parallel should be equal to 1 upon 10 plus 1 upon 10. So if we simplify this further, you will get the value of resistance in parallel as 5 ohms. So the experimental value and the actual calculated values are totally the same, which shows that our experiment has been performed successfully. The conclusion that we can draw from this experiment is that the equivalent resistance of parallel combination for our experiment was 5 ohms, which is in close agreement between the calculated value, and hence 1 upon resistance in parallel is equal to 1 upon resistance 1 plus 1 upon resistance 2. This expression is verified.